Okay, so what I want to start talking about today, we're going to switch gears a little bit, just so we make sure we get this in, is so what we've been talking about all the way up to this point is kind of a environment passing, but kind of a procedural based programming language. So we can kind of think about, we've been trying to invent our own version of like a C, something like that. Now, the major division then, when we think about our modern programming languages, is these guys are built as object-oriented languages. So object-oriented programming languages. Okay, so what makes a language an object-oriented programming language? What's the requirement? What's the difference between an object-oriented language and a procedural language? Start off with that. Long time ago, you had my little example of the telephone. Remember that guy? The procedural telephone was a big pile of wires. The object-oriented telephone looks like a telephone, even though we know the wires are stuffed inside somewhere. All right. So out of all the object-oriented languages you've worked with, so you've worked with Java, you've probably worked with C#, some of you probably worked with some other ones as well. What has been the main thing that exists that tells you this is an object-oriented language? What construct exists in all object-oriented languages that does not exist in procedural languages? Go ahead. Okay, so you've taken 2 steps forward. So constructors are components of what? Say it a different way. We will find constructors contained within a what? Class. All right, so all object-oriented languages have something called a class, where a class is a collection of constructors, fields, and methods, right? And really, if we were to, so we're going to call this guy variables. We'll call this guy functions. And this guy is like a special function for setting things up, something like that, an initializer. All right, so that's what a class is. So now let's think about this. So we're all good on that? So none of us have seen an object-oriented language that didn't have classes in it? All right, so with this in mind, I don't know why Clancy keeps moving this bar. Garbage. All right, so how are objects represented in our object-oriented programming languages? When we create a class, for instance, we, if we think about, I'll use some examples from CSC470 that you might remember. Remember when we created a little Dungeons and Dragons dungeon crawler thing? So we had inhabitants and all those guys. So remember we had an inhabitant class. And then we had, off of that, we had player, we had NPC, and depending on how far we got into your class, you might have had fighters and ninjas and stuff like that. I know we've gotten to that in some of the classes, but this is good enough for our model here. Okay, so this guy is a class that inherits from this class. So we'll kind of call these child classes, something like that. Ninja. Right there. And then we have our We'll say that's the parent class of that. Who's the parent class of inhabitant? Object. So all object-oriented languages have a top-level class, usually called object. Sometimes it's an Java, it's an uppercase O. In Python, it's a lowercase o. In C#, it's, I think, also a lowercase o. I'm not positive. Called 78%. But regardless, it's almost always called object. In fact, I can't think of a language that I've used that didn't have the top level called an object. All right. So as programmers, we work in this world. But the language has provided us that. That's our building block. So with that in mind, what does the top level object class do? What does that guy give us? What's his job? Because we're trying to understand, because effectively what I'm doing right now is forget about everything we've done this semester so far. We might integrate these two pieces together, but I want to make sure we get to object-oriented stuff as part of what we're doing here. Because I mean, I think we're at the point now with the rest of our language where we're adding features, but it's a matter of kind of time. We can just keep adding feature after feature after feature. Let's look at a different paradigm of languages. Now, hopefully you remember back when I first introduced object-oriented programming, I probably used an example, something like, I kind of call objects like Tupperware. It's just a new way of storing our stuff. That kind of goes hand in hand with that procedural telephone, which is a pile of wires, versus the object-oriented telephone, where you have this nice telephone-shaped box, and we shove all the wires into that, close it up, and just poke a few holes for the parts of it we actually need to manipulate, actually need to use that object, right? And all that other crap that makes it work is still in there. And if we need to get to it, we can. We actually go and write code. We have to get down to the nitty-gritty, but otherwise, when we're just using it, it's an object, okay? So we want to think about, if we build everything on top of this very generic object model here, the question is what does that object do? What does this guy have that this guy gets and then differentiates himself? Similarly, a player gets everything an inhabitant has and then further differentiates himself. An NPC gets everything an inhabitant has and then further differentiates himself, so on and so forth. So what does an object provide? Okay, so let's, I think you're on the right path. Let's start even more abstract. So this is going to create, this is a foundation on which to build other objects. That is to say, we do not intend to create generic objects. So this guy exists specifically to build upon. I'm not sure if that's grammatically correct. It seems close enough. Well, let's go that route. So we can think of objects, and I'll just connect it back to another object-oriented concept here. We're not going to implement that in here, but remember abstract classes? Okay, what's an abstract class? If we're dealing with Java, C#, any of our modern languages. If we make a class an abstract class, what does that mean? Pretty sure you covered it in one of your classes. What does it mean for a class to be an abstract? Go ahead. Okay, sort of like an interface, but it is different. So then tell me what an interface is. Yeah, so an interface in object-oriented languages, which is also an object-oriented concept. Interfaces basically say, this is the standard that an object must be compatible with in order to, like I use UPC scanners usually in class. where there's 10 different companies that make UPC scanners, and they all have to have, let's say, the same 3 basic features. After that, they can differentiate themselves, but at the very least, if you want to call yourself a UPC scanner, you got to be able to do these 3 things. That's an interface, because the interface doesn't say how you have to accomplish it. One of them could do like some sort of like actual legitimate logic. Another one might be doing some kind of magic or something. It doesn't matter how it accomplishes it, right? As long as it pretends, it doesn't have to do it right. It just has to claim it does it. Right? It has to have a button that scans, something like that. So an interface says you must implement these things in order to be part of the club, but it doesn't say anything about the implementation. A class is an implementation. Okay, so then with that in mind, now that doesn't mean it has to be a super, super strong implementation. And that's where you're already kind of along the right lines, because an abstract class typically would not have much of an implementation, but it very light interfaces cannot have an implementation. It's not part of the syntax for an interface. Classes can have implementations. Specifically, abstract classes may choose to have very little to no implementation, but it's a choice, not a requirement. So specifically, when we say something is an abstract class, what does that mean? Why would we make a class an abstract class? Well, we got to start off with, what does it mean for a class to be abstract? What does an abstract class prevent us from doing? Go ahead. Yeah, creating instances of it. So if we remember, abstract classes prevent us from creating instances of those classes directly. That doesn't mean they don't have a purpose. For instance, if we think about our, pun intended, I guess. For instance, if we think about our example from this slide, we are never going to create a generic inhabitant. We'll instead, in our game, we had players and we had NPCs. Okay. Human is a generic, is an abstract class. Nobody is walking around this world as a generic human, right? We further subdivide humans into males and females. Then within that, we have our own names, we have different color eyes, we have different heights, different weights, everything's unique, right? So we further differentiate ourselves. So nobody's going and saying, poof, there's a human. You're talking about, oh, I saw Brocker, okay? That has context to it. Like the person that is Brocker means something to people. If you say, I saw Blade, that means something else. I saw Dr. Locklear, that means something else. They're all humans, right? But they are specialized versions. So we would never actually create a human. So in that particular context, we would say that the human class would likely be an abstract class. It might have some implementation, right? Because all humans have many things in common with each other. But then all of the instances of humans that we see walking around are more than just that, right? So we build them in terms of that basic blueprint, but we never actually have the basic blueprint walking around, okay? So an abstract class prevents us from creating instances of those classes directly. We can't create a human, but we can create a person, a male named Brocker that has all these other things. We can create that, and within that creation, a human was generated as the basis. You are human, but then you're more, right? Even though we've said it's against the rules to directly create a human. We create specialized versions of humans, but indirectly, we could say abstract classes are indirectly instantiated by the inheriting class. So as programmers, we can't directly create instances of them, but when we create an instance of a player, an inhabitant is generated, is instantiated on which to build that player using this picture. That makes sense? Okay, so if we use this model right here, what does inhabitant give us? We don't have to go into too much detail, but in general, maybe we say that all inhabitants. This is really an inconvenient bar. Wish they had like a little way to just minimize it. It'd just be a little pocket right up there. Can you? But how do I get it back? Ah, star for the day, Brocker. Drop and give me 20. Which one was that? Hide fluid. That's amazing. How come I didn't know that? I need to get better at computers. It's one of those like stupid things, like you assume that probably is there, but it's like so annoying, like this is just in my way. Does everyone always just move it? My wife will get a kick out of that. All right, so if we just think generically, maybe we say that, okay, all inhabitants have names. So that guy has a name, and maybe an NPC. I don't know. I'm just going to make something up. An NPC has a allegiance. They're part of some faction or something like that, where maybe a player, they have a socket connection. We'll just throw a little bit more advanced stuff. So they have an open internet connection that they're connected into their video game, and there's a communication channel between them and, where the NPC, the NPC is not sitting in somebody's living room, right? Although that would be kind of, game masters in some of these games can do that. They could take over NPCs and control them. Wouldn't that be interesting that you could, if there was a game that came out where you actually, part of the play style was you could be an NPC? Like, what are you going to do today? Well, I'll probably spend 7 or 8 hours running that shop, selling potions, just chilling there. And people come up and you're AFK, trying to buy bread. All right, we'll just say socket connection. Good enough, because really we're going to be working with this up here. All right, so we're saying that, okay, all inhabitants have names, but then players and NPCs get a little bit of a special sauce, whatever. Okay, so then my question for you is, what did object provide to inhabitant? So at this level up here, if I'm telling you objects exist, what do objects give inhabitants? And to answer that, we have to think about what is an object. So we think about our modern languages. If I create any kind of object, so an instance of the random class in Java or something like that, and then I go to print that out. What prints out when I print, have some kind of object? Memory address thingy. Okay, so an object takes up, it's a physical thing in the world, right? It's representative of a physical thing in the world, and it's going to take up a piece of memory. Okay, so we can say that what is an object? It represents a physical entity in the world. We know where it is located by its memory address. What else might we know about an object? What else might an object be able to do? If we think about Java, for example, objects have a toString, right? So Java objects have a toString method. Why do they have a toString method? How is that toString method used when we talk about Java objects? remind you a little bit. Let's go into, can I hide this thing? Can I hide that thing? Probably not. Let's put that down there. So let's do system class Java. I think it's a print stream I'm looking for. System.out is a print stream. All right, print streams have a bunch of methods. Famous ones are this println, right? System.out.println in Java. So notice we know how to print a Boolean, a char array, a double, a float, an int, a long. We know how to print an object. So one of that, what is it? What do we call it when you have more than one method with the same name but a different number in or type of parameters? Polymorphism, good. Did you know that, Clancy?
Maybe. I've definitely heard the term before. And I think we've talked about it in other classes.
You've definitely talked about in other classes.
Yeah.
I think I bring up polymorphism in like every one of my classes. I guess it's all kind of hit and miss. It all depends on what pops into my brain those days. That's what happens. Actually, yeah, we've told that story before where Sarah yelled at me. It's like, I gave a test with something on it that I was sure I had covered. Like, well, I've covered it before. Probably should be more prepared. It's just all stuck up in here. It's terrible. I learned my lesson though. Now I have Sarah proofread all my exams. I probably should. It would be in my best interest. All right, so in any case, this is polymorphism where we have a whole bunch of methods with the same name but a different number and or type of parameters. But notice that one of these guys here knows how to take in an object, okay? Object, this is the most basic real thing we can have in an object-oriented language. And because it takes in an object, it has to assume. So what println for object does is it calls whatever that object is, it calls its toString method. That's what it does. And how can it have confidence that it can do that? If we go into the object class here, we see that we have a toString method. This is the dude that gives us that memory addressy looking thingy. All right, so there is a promise made to us that all objects will have that functionality because things higher up in the language are reliant on it. Now, that doesn't mean that if we're making an object-oriented language that we have to, be a good neighbor to some future print method, right? We don't have to be nice to that guy and provide some basic functionality of identifying ourselves, but it makes some sense, right? We should have some way of like, look, you probably aren't interested in this information, but if you don't have anything better, this is where you can find me. Here's my memory address, right? Okay, so if we kind of look through this list, first of all, you see it's not that big of a list, right? Objects are relatively simple compared to some of the other things we've seen, all right? But what are the things that a Java object? Now, we presume that a Java object is probably a fairly complex object. I mean, it's a better language than what we're writing, correct? It's more well thought out, been through its paces, stuff like that. So what I'm saying here is that the most generic object in Java really isn't overly impressive in and of itself here, right? One of the things is we can clone it. Okay, so why would we want to clone it? Well, objects are passed by reference by default, right? So if we were going to change an object inside of a function and we didn't want those changes to be permanent, we might want to pass it a clone of that object. Make sense? That'll just copy the memory to another memory location that we're changing. So we can pass anything that is an object, we can pass it by value. Instead of, well, it's still passed by reference, it's just a brand new pointer to a new place in memory by cloning it. Something that maybe I'm guessing most of you probably have not used it before, but it's something you could use. If you really, really, really wanted your object, because it doesn't have to be with a generic object. I can say, look, I'm gonna, where's this guy here. I'm gonna have this player go into a room and fight something. But, I don't want to die. So I'm going to clone myself first. I'm going to send the clone in. I don't really care what happens with him. I want him to clear out the problem, right? And if he dies, I'll just clone myself again and send a new one in, okay? I don't want side effects to impact me, right? Now, under normal circumstances, though, if I were to pass myself into my death match function, right, where I'm fighting the rat to the death or whatever's in the room, right? When I take damage, I took damage, okay? So in real life, we might say, well, that's normal, right? You touch something hot, you get burned, it hurts, and it's just gonna hurt for a couple of days. But if you don't want it to hurt, you can clone yourself. It's a skill I have, and a couple other people have, but it's rare, is what it comes down to. Okay, but the punchline is this is given to all objects, whether you ever use it or not, it's there. Okay, Java has basically said, we have a way for you to pass a copy of an object if that made sense to you. And this will work for anything that is an object because it came from the base object class. Make sense? All right, so kind of keep going through the list. We can compare objects to other objects. This is saying we're matching memory addresses. We can finalize an object. This is something that's available because Java is a language that supports automatic garbage collection. So when the garbage collector comes through and says, hey, you have a pointer count of 0, meaning nobody loves you, right? Nobody's interested in you. Nobody is a pointer to you. You're sitting here wallowing in memory that somebody else could be using. You were literally a waste of space.
I can relate.
That's when the garbage collector takes advantage of his knowledge that since you are an object, you have a finalized method. And is it suicide? Let's see, an object when the garbage collector. Yeah, it doesn't really clarify who kills who. It's unclear whether the garbage collector is, I don't know, grinding you up, whatever he does. Clancy can look it up. Or he just says, look, you're done, die already, something like that. But in any case, the garbage collector is reliant on having this like off switch, if you will, for all objects that are in there. So that's something that an object says, because objects eventually are not being used. They need to give their memory back. So this is the little hook that Java has given them to allow it to be reclaimed. But this only exists because we have this automatic garbage collector thing that's there for cleaning up memory. We can get the name of the class or get the actual class object associated with an object. Hash code is going to be like a hash value is actually, any of you know what a hash value is? Maybe from the security class? Why don't you know? No, they got a stick. Go ahead. It's often used in encryption. Yep. What do you think, Clancy? You know what a hash value is?
I've definitely heard it. I just don't know off the top of my head.
I'm done with you. Noah.
He's senior.
See, now we find out whether he even heard my question. Do you have the answer to the question?
What a hash value is?
Yeah.
Yeah. Isn't it just where it's like it's encrypted on the top, and underneath there's like a secret encryption code so that only the program will know what the actual value is, but the user just sees the hashtags.
I don't think you're any closer than Sarah in saying, isn't it an encryption thing? I actually think you said you were better off. You said some wrong things. But at least
I tried.
An example of a hash thing that you've seen in the wild is MD5, Message Digest 5. You download some 9 gigabyte file or something like that, then they sometimes have this MD5 thing, hash, that's like, just fixed size that you can compare it to. So a hash value is a one-way cipher. It's a math function you apply to an arbitrary size input. Doesn't matter how big your input is. It could be 1 byte. It could be 9 gigabytes. Doesn't matter. It gives you a fixed size output. A fixed size output. So regardless of size input, it gives you a fixed size output, which then means you potentially can have collisions, right? You could have two separate things, two completely different files that have very different sizes that technically could hash to the same output, technically. Now, a lot of times you have like a 256-bit hash, which means you have 2 to the 256 unique hash values. So you think this is unlikely, but not impossible. But that's what a hash is. So built into Java, we have this idea of, hey, give me your hash value. It's probably using MD5, or some message digest. That's what MD stands for, some message digest. So hash values are often used for like password protection. If you've ever gone to, excuse me, if you've ever been to a website, you want to reset your password. Have you ever been to one of those websites that they just send you an email with your password in it? Say, hey, this is what your password was? That's an insecure website if they're doing that. They exist, right? I've definitely been on sites like that where I say, I forgot my password, and you got to give them like your username and your email address or something, and they'll send you an email with your password in it, like the password you set up. Okay, but that would be bad news bears. So instead, most places, they store your password as a hash value. They don't actually store your actual password. They have the hashed value of your password. They couldn't tell you your password if they wanted to. So when you log in, what do? They hash your password that you typed in, and they compare the hashes to each other and say, did these equal the same thing? So technically, in some of these cases, somebody could get into your account if they had the right username, but a different password that happened to hash to the same value. It's kind of more interesting trivia stuff. It's unlikely, but it is possible. All right, so that's what the hash code thing is. Notify, every thing has a single thread associated with it. This wakes it up. Notify all. So basically the punchline for this is threads in Java. When you want to wait for a thread to finish, you have to join that thread, and that's a true statement in any sort of that's a common thing for waiting on a thread. You join the thread. This guy would be the antithesis of that. We notify the people that are waiting on me, something like that. All right. We can wait, a couple different ways of waiting. That's it. So most of these things in here were quality of life stuff. Like, hey, you can clone yourself, but is that a requirement? No. Look, you don't want to get beat up, don't go into the room. Don't send your clone in. We don't have to let you clone yourself. Okay. Quality of life equals, that's something that we might say, hey, I'm interested if two things have the same memory address. So maybe that's a core functionality of a language. And we could say that probably belongs in most of our implementations. Not a requirement, but belongs. Finalize, waste memory. Who cares? We don't need that. I have plenty of memory. I'll reboot my machine often enough, right? That really is the way that we could use our computer today, right? You got 16 gigs of RAM. You reboot your machine every couple of weeks, you're probably fine. It won't run out. just keep taking up the space, okay? So a lot of these are quality of life things, right? So at the end of the day, what does an object actually have to have in it? Especially if we're implementing it through an interpreted language, kind of like a Python interpreter. If we go back to our picture here, does this guy actually have to have anything? Go ahead. That's it. He probably needs to exist. So really what we're saying is this guy he could be basically an empty husk, but he has to be an empty husk that exists. So we can say at some level, he has a memory address, right? Realistically, in Scheme, we would probably create maybe an object as I don't know, an empty list or something. We come up with some representation for our object. And what is that? That would be the memory address. He's your spark. You know, he's your core existence is that object. That makes sense? So I'll put in, so I'll just say something like this. Must exist as a thing. We might think about that in terms of it being a memory address. Make some sense? Okay, so it must exist as a thing. We can think of it as being a memory address. All right, but at the end of the day, if I'm just looking at this like I'm playing with Legos, I just need this little blue Lego because he's my starting point for all of my creations. I never actually have to know his memory address. I can just see him. He's right there. My Lego. Pick it up. So he just has to exist. And he's my starting point. He's the foundation on which we build all other things. Now, the less stuff this guy has in him, the less, let's say, universally useful stuff that guy has in him, the more stuff we might have to build into our first class that inherits from him. You know, so for instance, if I want to be able to print out an object, which is not a requirement, right? I mean, think about the first objects we wrote in, so you had objects the second half of 200, all of 250, all of 300. So when the first thing we pretty much wrote on any object was like a display method, right? Print out 1 or 2 or 3 of the fields, and that's what you look like. So instead of calling system.out.println on an object, we can just tell the object to display itself. That's good enough. We could have gotten by without ever having the convenience of saying system.out.println on an inhabitant. Life would have gone on, right? So we don't need to have some of those things, but now we basically say, look, if you want to display something about an inhabitant, yeah, you got to call display. Fine, you got to do a little extra work in your later classes. Okay, and then, this is kind of our inheritance model that we're saying here. So inheritance always exists. So as programmers, when we first get started, we view inheritance as like a more advanced concept of learning about objects. When the reality is you used inheritance the very first time you created an object, right? We see it in other languages. We do not see it in Java. If you create an object in Objective-C, an older language, it says that guy comes from NS object. So if I look, have I told you that thing before? We heard of Next Computers. Have I told you the story of Next Computers before? Oh, Clancy, you don't know anything about Next Computers?
I'm not sure. I don't think so.
All right, well, it's related to what we're talking about here. It's a little bit off topic, but it's really important for the history of computers. So let's just go down this path.
I might know it, but I feel like I need a reminder.
That sounds made up.
Sometimes it just takes something to jog your memory. And then
No.
you're like,
Yeah, who was Steve Jobs?
oh, dude, I have no idea. Doesn't sound like an important guy at all.
Who is this guy? Apple computer guy? All right. So founder of Apple Inc. All right. That was like in the late 70s-ish, 77, something in that ballpark. Okay. Now, did he work for Apple his entire career?
No,
What happened to him?
he got fired from Apple.
He got fired from his own company. That's the risk that you take when you go public, when you become a publicly traded company and you have a board. The board can fire you even if you were the founder. So he got fired from Apple. What did he do after he got fired from Apple?
Didn't he start Pixar?
He actually bought Pixar from Star Wars guy, George Lucas. George Lucas was going through kind of a rough divorce, needed some cash. I think Steve Jobs bought Pixar for, I don't know, something like 8 million, something like that. Sold it to Disney several years later for like 8 billion, and remained the head of the board. That's a good deal. Just like, hey, give me some cash. My position has not changed. That's a good gig. All right, so he did Pixar. What else did he do when he got fired from? So we'll say he got fired from Apple. You know, bought Pixar. Probably none of you have heard of Pixar though, right? They haven't done much. All right, so I mean, a couple, I don't know, like cartoony type movies. Not successful. All right, so he bought Pixar. What else did he do?
He started Next Computers.
All right, started Next Computers. What was Next Computers? First of all, we'll show you a nice little image. Next Computers, images. Yeah, here's their logo. He spent a fortune on this logo. Yeah, there's Steve Jobs with the Next Computer.
Wasn't it supposed to kind of be like a rival to Apple?
Well, not directly. I mean, back then the issue was compatibility. You had, you know, if you had a floppy disk that was formatted for Mac and you put it into a PC, it said you need to format this. If you had a floppy disk formatted for PC and you put it into a Mac, it says you got to format this. So you couldn't go between the two machines. There was no compatibility. Well, Next was supposed, it was kind of targeted education, universities. And it was a Unix-based operating system that was supposed to kind of bring compatibility together under a single umbrella. All right, so that was Next Computers. All right, so we started Next Computers. All right, so how did he come back to Apple?
Apple bought Next.
Yeah, so Apple, actually, it's kind of a funny thing. Apple was failing as a company, falling apart, out of money, going to close their doors. Anybody know one of the reasons why Apple was failing as a company? Probably the main reason they were failing as a company. When you think of Apple today, what do you think of? Expensive, proprietary, and the word proprietary we view as a negative term, right? That's Apple's secret sauce, is the fact that it's proprietary. You're going to have the best experience with Apple products if you exist solely within the Apple ecosystem. If everything in your life is Apple, everything just works. The second you throw one little curveball in there, one family member has an Android device, iMessage doesn't work, you know, like, oh, did you get the blue or the green text? You know, you get all that, nothing works anymore. Life is over. Your calendars aren't syncing. Ask me how I know. All right, so Apple was pressured into, for a long time, well, they were proprietary and expensive for a long time, but they were still popular. But then they were kind of pressured into allowing other people to create clones of their hardware. So you could get a Power PC, which was the Mac Power PC, Power Mac. You could get that made by other companies, and it was compatible. It was a Macintosh compatible computer, just like we have PCs made by a bunch of other companies. Didn't work. Apple almost went out of business. Apple was a hardware company. How do you make money as a hardware company if somebody else is selling hardware cheaper than you are that's compatible with what you have? You don't. Right? You go out of business. So he came back to Apple. So Apple acquired Next Computers. Steve Jobs was made interim CEO. ICEO title, interim CEO. He also paid all their bills. Kind of funny how you acquire a company that comes with the CEO of that other company who you put as your interim CEO and expect him to pay all your bills because you're out of money. So Steve Jobs came back and saved his old company that fired him. What happened to Next Computers? This is the kicker. Anybody online now?
No, this is where my knowledge trails off.
We're going to look up some documentation for modern Mac software. So we'll do Objective-C object class. So first of all, this is, and I am relating this to what we're talking about. I was giving you a story here. I mentioned that your first experience with objects using a language like Java was likely that you didn't see that it actually inherited from object. In Objective-C, Objective-C is the object-oriented version. It's the competitor with C++. Microsoft wants C++, Apple went Objective-C. They hated each other. Didn't matter which one was better. They did not with the other directions. So here is a class in Objective-C, and it inherits from something called NSObject. So it's still got that word object in there, right? What do you think the NS stands for? Next step. How many of you are Mac users? Have a Mac? Access to a Mac? Did you realize you're actually a Next Computer user? Apple died. Nobody noticed. Apple died. Right around that same time, what came out? Click. About this Mac. This is Mac OS. This is Mac OS X, 10.15. X. Does it stand for 10 or does it stand for X in Unix? Is it a coincidence that Next Computers ran on Unix? And all of a sudden, Mac computers, they say, oh, we're going to get rid of the old operating system and have a brand new one that nothing that your old stuff, all your old stuff isn't compatible with the new one. Big surprise. Because it's what came from Next Computers.
So did they pretty much pay Steve Jobs to take Apple then?
Say this again?
Essentially, they just paid Steve Jobs to take Apple back.
Something like that. I don't think there was very much money involved in the acquisition of Next. There might not have been any money. Oh, what do? They slapped a Apple logo on top of Next Computers, and Steve Jobs was able to use Apple's manufacturing process to continue evolving Next Computers into what has become Apple today. And then along the lines, you had the iPod and the iMac and the iPhone, all that stuff. Each one of them generating a little bit of money. So they did okay. But it's kind of like the best kept secret, I don't know, almost feels like in the history of computing. Nobody actually realized that Apple died. They never filed for bankruptcy. Instead, they just became another company that was wearing their shirt. It was wearing their logo. Kind of a fascinating story, but from a computer science perspective, we see the evidence of that even today at the code level. Today, the classes in Objective-C, they're called the Cocoa classes for Mac development. The base object is called an NS object, next step object. You also, so this is why I'm a big fan of Objective-C. So you also see here, when you're creating an instance of an object in Objective-C, here's your type, variable name, and when you, if we were in Java, we would say box1 is equal to new box. What's the new keyword do? Gets us memory and is always used in conjunction with a call to the constructor, right? What does the constructor do? Initializes a variable, right? So you would say that when we first build an object, new memory is created and the initializer for that object's called allocate enough memory for a box, then call the init method. Everything's just right there in front of you. But all that stuff's hidden from us now. Now we just say new box. New, yeah, it makes memory, I don't care. Well, what's the box part of it? Well, it magically calls the constructor. Well, this guy, the constructor's name was init. If you wanted to call the constructor elephant, you could have. Didn't matter. So just kind of an interesting thing here. Let's see yeah, so here's the constructor for this guy. Called it init. It returns, this is an identifier for the memory address. And what did it do? This is actually even the better part. Still related to what we're talking about today. I'm just wrapping it in a story. One of the things we rely on for our object-oriented languages to have is to have this core variable called self or this or me or whatever, some way for an object to refer to themselves within themselves. Now, in Java or C#, you just magically get that variable called this. In Objective-C, you don't. How do you get it in Objective-C? What's the very first thing you do in the constructor in Objective-C? You say parent, and who's this guy's parent? NS object. You say parent, you go ahead and call your generic constructor, whatever that means, and give me my base identity. In Objective-C, we actually had to write that line of code. And at the end, what did we do? We returned that pointer to ourself as an ID. Every single time you wrote a constructor in Objective-C, you were building a sandwich. You always had this line first. You always had this line last. And then you did the things that differentiated yourself there. Make sense? Here's your evidence. You've seen the stuff that Java and C# are hiding from you. All that crap is still happening. That variable this had to come from somewhere. They didn't just pull it out of thin air. They just said, look, we're not going to make you waste your time writing this over and over and over again. Where do you get your initial identity? Get it from my parent. Why? Because that was my base. Exact same thing we're talking about right here. Where did an inhabitant get their initial identity? From their base. Where did player get their initial identity? From their base, which got their identity from their base. This is how object-oriented languages work. All right, make some sense? Okay, so I think you maybe heard me say before that Objective-C is among my favorite languages. To this day, I just really like how it, I don't know, I just like how it just spells all of it out for you. It reveals so much about what's happening under the hood. Similarly, in Java and C#, you have static versus non-static methods, right? Class methods versus instance methods. And how do we tell them apart? Well, it's an instance method if we don't see static there. It's a class method if we do see static there. So the omission of something means it's something. I don't know, that doesn't make tons of sense to me. In Objective-C, instance methods had dashes before them. Class methods had plus signs before them. So a static method had a plus, an instance method had a minus. You had specific syntax differentiating them from each other. Not it's either there or not there. I like that better. So, and then this goes back to the old punchline where when they came out with Swift, when Apple came out with the Swift programming language, You know, they were really doing it because Swift, if you've ever programmed in Swift, minus the emoji stuff, which I think I've made fun of some other time in here, but you know, it looks a lot like Java because they're trying to get the Android developers over to the dark side and write stuff for iPhone. So they need to give them a language, because most of you would probably look at something like this and at the very least say, this is a little bit intimidating because the syntax has these square brackets. It's new, right? We don't like new. We like curly brace stuff and then the new keyword stuff. And oh, anytime I see alloc, like if you've had the 450 class and we're you know, you're allocating memory, that we actually in 450 we use malloc to memory allocate. Did you guys you had 450, didn't you? Oh, none of you have had 450? Oh my God, that class is a nightmare. So we write C in there. Operating system programming class. Is it next semester? Hey, do I teach it? Hey. Yeah, so we'll write C in there where we allocate. We're working with memory all over the place. All right, so I just love languages that are explicit and they show you what's under the hood, because it makes you appreciate that. When you imagine as a more modern programmer, it's great to have power tools that let you accomplish everything, right? But if you never saw the other stuff, you don't appreciate what's under the hood. And then we come here in a language theory class and we have problems closing that gap because there's some stuff in the middle that we've always just assumed was there. But then now we have to ask ourselves, well, where did that come from? Came from somewhere. Okay, is your own identity, the identity of self, this, whatever you want to call it in your language. You can just call it dude. You know, whatever you want to call it. That had to come from somewhere. It has to mean something. You have to have a way of talking about yourself from within yourself. All right, and human beings, we do this all the time. We say, I went and did this, right? We talk about ourselves by saying I. People look at us weird if we say, well, you know, Mike went to the movies. You know, it's like funny for a little bit, but if you have like one of those friends that does that all the time, they're not friends for long, right? Yeah, you might want to check their search history. There might be one of those bronies. If you don't know what that is, before class we were talking about My Little Pony fan fiction, and apparently there's a group for that called Bronies. That's like an all guy organization that are big fans of My Little Pony. And that's as far as we're going to take that conversation. This one, we're just ending that one there. All right. So in any case, getting back to now that you realize that Apple isn't what you thought it was. So all you iPhone users, you're using a Next phone with an Apple logo on it. Yeah, which is fine. It was an improvement. That's when Apple saved itself and became the Apple that it is today. Right? Switched to Unix as an operating system, switched to Intel as a hardware architecture away from PowerPC, came out with the iPod, came out with the iPhone, iPad, iMac, iBook, which actually kind of disappeared. Have you ever seen the iBooks? Oh, iBooks were fun. They had their own little carrying handle attached to them, and they would look like fruit. Here, I'll show you a picture of one. Yeah, look at this guy. They had their own little carrying handles. There was a handle up here, it just kind of flipped out. Doesn't that look like Mr. Gonzalez's computer? Oh, there's their handle. I wonder why they died off. I think what ended up happening is Apple went away from kind of fun to being like premium, right? So instead of being, I guess they went from, trying to think like what's like a fun version of a car to like a Cadillac. They decided to do everything with like premium material and you know, all their new stuff is about, you know, how they've, you know, made their own alloys. Like, well, normal gold wasn't good enough. We mixed it with, you know, contents of a star and an asteroid and dark matter. And then we charge you a ton for it. And by the way, it's going to be antiquated in a year. Trade it in for a third of the value and buy a new one for 20 grand. With no charger. You don't get a charger. Actually, you get the cable. They just didn't give you the new iPhones. That's the joke. The new iPhones didn't come with the little brick that you plug into the wall. You still got the USB cable. I mean, how many of you have like 50 of those bricks laying around? You're like the modern day version of the D4. You have it laying on your floor, you step on it and you just black out because you scream too loud. Been there? You've never stepped on a D4. That would be a great challenge for you, Clancy, to videotape.
Is brick the actual technical term for that thing?
I don't know.
I've always called it a butt.
Called it a butt?
Yeah, it's the butt. It's the butt of the charger.
I don't think I've ever heard that before. You have to keep in mind that in the last 21 years, I've spent like a bunch of time with like just college students. So you hear all sorts of stuff. All right. So in any case here, you know, when we think of an object, one of the things that we consider must be there is some way of talking about themselves. And this actually goes hand in hand with the idea of it existing. Because in that Objective-C example I just showed you, what did we ultimately return? We returned self, who we are, memory address, the pointer to ourself. We have to have some way of talking about ourselves from within ourselves. So we can think about this as self or this or me. The only language I've ever seen that uses me is Visual Basic, and I think that's the only reasonable thing Visual Basic actually brought to this earth, was that they use that. But most of our modern languages either say self or this. Similarly, we also bring to the table the idea of super, where super is the instance of your parent. All right. And this goes back to what I said a little bit ago about the idea that you cannot have a user created object without using inheritance. Inheritance is core to object-oriented programming. It's not a feature. It's not like a bonus feature of it. It's core to how it works. Since by default, we have a base Lego that we build all objects on top of. And even the simplest user-created object inherits from that dude. Okay, make some sense? Okay. All right, so assuming we're going to start building an object-oriented language, we'll start off probably in a second file, and then possibly bring it into our current one or just build on top of that, just looking at basic object-oriented stuff, knowing that we could glue the two together if we wanted to. Because another thing is our current interpreter is getting a little bit beefy, right? So maybe starting with a fresh thing from an object-oriented would make some sense. But how can we represent the top level object in Scheme? Remember, our goal is to have that Lego, that building block on which all other objects are created. What would be a good default representation for a object? We can think about this in terms of our constructor. We'll call our constructor, right? For our, we would have constructors. Constructor for a basic or for a generic object. And I'm going to go ahead and create a new repository here. Oh, did we ever write a multi-threaded merge sort when you were in 250? Oh, that was a blast. We wrote that today. In fact, just since we aren't going to have a ton of time to get into this object building thing, let me just show you that real quick. So merge sort using threads in Java. So if you remember, merge sort used recursion, right? Which is a feature that we have used heavily in here, right? Recursion. You actually even wrote sort of kind of a merge sort in one of the early functions that we wrote in this class. But you know what I did here first was just filled up an array with random numbers between 0 and 1,000. So that's just unsorted values, and then printed it. Then I created a single thread. So I had this thing called a merge sort worker B that said, look, I want you to sort this array from bucket 0 to the last element in that guy. And then I told that thread to start. And this is what that thread does. So when the thread starts in Java, this guy extends thread. So it inherits from thread, and thread implements something called runnable, which makes it it must have a public void run to be compatible with runnable. But we extended thread, so we already got a generic public void run that didn't do anything, but I wrote my own here. And you know, he just announces himself that, hey, I'm going to start working on the part of the array between begin and end. The idea being, instead of doing this recursively, we're going to spawn off a whole bunch of threads to work on different parts of the array. It's still like a recursive call where we're saying, look, I can't do anything with it until the two of you do something with your parts. And then each one of them say, well, I can't do anything with it until the two of you do something with your parts, so on and so forth. All right. So as long as this guy was something other than a one list, what did I do? I figured out the two halves. I created two more worker bees for the left half and the right half, told each of them to start. But then before that merge step, before I could actually merge the two halves together, I had to wait for those two threads to finish before I can move forward. All right, over and over, and then I did my merge step. You know, this one's just reasonable number of lines of code by asking simple things, which is smaller, pause 1, pause 2, otherwise, and pick the winner, and then copy the stuff back over into AR. All right, so that is a multi-threaded merge sort. I'm printing it out there. So we see originally, this is the unsorted version of that guy up there. Then you see we have all these threads that started working on that from, and look at the portion. This guy's working on 0 to 19, 0 to 9, 10 to 19, 0 to 4, 10 to 14. So these guys aren't even right next to each other, right? They're working on different halves of this thing. So we have all these different parts happening all at once. And then once they've all finished, I'm stuck with a sorted array. Doing it all with threads instead of recursion. And what's the advantage of multi-threading versus recursion? What's the disadvantage of recursion? Thinking about it from the perspective of what we've done in here.
Memory.
Yeah, memory. You eventually run out of stack space, right? You keep calling it, you run out of stack space. Now, we can say that multi-threading, so a thread is like a lightweight process. So we have, you know, multiple copies of our program, we can think of it like that, all running at once, focusing on different parts of the array. And the reason we can pull that off with merge sort is merge sort can be divided into individual pieces. We're ultimately reliant on certain things being finished before we can merge them back together, but we can focus on those individual parts simultaneously, right? The same thing goes for video conversion. If any of you have ever, downloaded a movie or something like that, or had some, large animation project or something, and you want to turn it into an MP4 in the end, that takes time, right? And even when you're rendering your animation, that takes time. And animation of any sort of size takes some reasonable time. If you're doing it on your laptop, it takes a lot of time, right? You might have something stupid. You got to wait an hour for the thing to render. Then you get some powerful machine that has 48 cores in it or something like that and uses the GPU to do some of the stuff. And something that would have taken an hour on your laptop can be done in like 2 minutes on one of those machines. Same thing with converting video files. If you, because you can convert different parts of the file at the same time. So the more processors you have, the faster you can convert it. And it's like astronomical. You might have a video that would take you 45 minutes to convert with a medium power laptop, and it would take a minute and a half on some beefy workstation desktop. When under normal load, if you were just using those two computers themselves, they would feel very similar speed, right? Most of your laptops and stuff feel just as fast as the fastest computer you've sat in front of most of the time. You're checking your email, you're browsing the web, you're writing some code, whatever it is. They're perfectly fast for those things. Only when you need to do some real crunching, rendering an animation, doing something like that, does the resources you have under the hood actually make a difference, right? So multi-threading is kind of we can say that, obviously I created a lot of threads here, right? So we probably weren't overly efficient, where I spawned off a thread to look at 2 1 lists or something. But what if this was done? What if we say a thread is the gateway drug for distributed computing, where I actually take each of those threads and instead of running them simultaneously on the same computer, I say, this computer does this part, that computer does that part, the next computer does another part. And then when you're all done, we'll bring it back together and we'll do the merge. Get what I'm saying? Because now you're not fighting over the same resources. You have multiple computers. So now if you have huge data sets, you can simultaneously sort that data set in a fraction of the time it would have taken to do it on a single computer, even using multiple threads, because eventually, you're creating 50 some threads here, 30 some threads. I think it started with like 20, right? Whatever it was. Yeah, you're creating a bunch of threads. Those are all competing for the same CPU time on my computer. And so fine, my computer has, I don't know, maybe 16 core or something like that. It's a lot of processors, but not enough for them to all run truly simultaneously. All right, that makes some sense. All right, so what we're going to look at next time is, I'll go ahead and start our repository next time, is we want to create a constructor for our basic object and then start building. So we're going to be building our Lego that we can build other objects on top of. Okay, so go ahead. Potentially. Actually, you wouldn't even have to have memory address. We can just have a list that has object in it. But then we need to say, how can we now use that through inheritance? So we're going to have to build that framework. So yeah, to your point, it's going to be easy to create the baseline. And then we might have to go back and add some stuff to it if we need extra stuff later on. But we'll start that process on Tuesday. So no homework over the weekend because we're not far enough to start that. But make sure that you have gone through and you at least understand the basics of object-orientedness from a nuts and bolts perspective, the things we talked about today. We'll start writing our object next Tuesday. Questions, comments, concerns, bribes? Okay. See everybody Tuesday.
Adios, senor.
Later.